Alright, hi guys. We're going to do a video here practicing some of our graphing skills, and it's really focused on two things: graphing absolute value equations and just graphing inequalities in general. And so we're going to do this kind of as a review video where I'm going to post a problem like this first one, part A, and I really want you to pause the video and just do the whole problem yourself first, and then unpause it to see if you did it correctly. That way you know you're kind of ready to move on to the next topic in class. So our first one, part A here, is we're going to graph, and I guess I could add that to my directions up here. We're really focused on graphing for this video. So we're going to graph y is greater than absolute value of 2x. Will you pause the video and see if you can do this whole problem yourself? Okay, so hopefully you've kind of paused the video and you're ready to check and see. I'm going to show you kind of my general setup here. Typically, when I have an absolute value problem, in almost any graph really, I like to set myself up with a table, and I just got kind of a blank graph ready to go. And this is just kind of like the skeleton of my problem. What I'm going to do is I'm going to take some kind of basic numbers here for x, like -2, -1, 0, 1, and 2. And I'm going to basically substitute them in, plug them in to the absolute value of 2x. So for each of these, I'm going to do absolute value of 2, but instead of 2x, 2 times -2. Or the absolute value of 2 times -1. Absolute value of 2 times 0. Absolute value of 2 times 1. Absolute value of 2 times 2. And I'm going to kind of just simplify this up so I can plot some points. So 2 times -2 is -4, but absolute value, that'd be a +4. 2 times -1 is -2, but absolute value is a +2. 2 times 0 is 0, the absolute value is 0. 2 times 1 is 2, absolute value is 2. 2 times 2 is 4, absolute value is 4. Okay, so I get kind of a pattern going on here. 4, 2, 0, 2, 4. So what I'm going to do is I'm going to plot those points over here on the graph. I'm going to put -2 and 4 at -2 and 4. Put -1 and 2 right here. 0, 0, 1, 2, and 2, 4. And sure enough, it makes exactly what I expected. It makes a V graph. Every time I think of absolute value, I tend to think of these graphs, these sharp V's. But what I'm not going to do is connect my points right away because I need to pay attention to the rest of the question. Remember what the rest of the question said. The rest of the question was y is greater than absolute value 2x minus 4. So remember what that means. Greater than means that if I test a point on the V, it's going to fail. There's no equal sign. So this is going to be one of those problems where when I connect it, I take my ruler and I connect it with a dotted line. It will not be a solid line. Now if you don't believe me, you can totally test a point on the line, on the absolute value equation, and it should fail your test. If you don't know what I'm talking about, then you need to back up and watch some older videos on how to graph inequalities, because you should know how to test points by now. Now I have one other thing I need to do. I need to determine where I'm going to shade. Inequalities tell me it's a graph that needs some shading. So if y is greater than this absolute value, I'm going to test a point either inside or outside of the V. Either I'm going to be shading everything outside or I'm going to be shading everything inside. So why don't we just test like 0, 5, something kind of simple, and I'll go up here and I'll test 0, 5. Now remember, 0 is your x and 5 is your y. So if y is greater than absolute value 2x, what I'm going to do is I'm going to change y into 5 and x into 0. And I'm going to see if this is going to pass or fail. So 5 is greater than absolute value 2 times 0. 2 times 0 is 0. 5 is greater than 0. Is 5 greater than 0? Yes, it is. Oh, okay, pass. That is a true statement. And because that's a true statement, this point at 0, 5 passes our test, which means all the points inside the V should pass our test. Every single one of these. So what I'm going to do is I'm going to use my pencil and just kind of shade this in. And this tells somebody who's looking at my graph that any point inside the V is a solution. And that is going to make my final answer, that graph. I might write the equation y is greater than absolute value 2x right next to it just to add that on. But then I feel pretty good about this graph. So hopefully that's what you got when you paused the video and did it yourself. So we're going to do another one here, part B. And B is going to look like this. Y is less than or equal to absolute value x minus 2. Okay, pause the video, do it yourself, and we'll see if you got it right. Okay, so I'm hoping you're unpausing the video now, and you're ready to check your answer and see if you did it correctly. And hopefully you made a table. And again, I always start with these numbers, -2 to +2. I'm going to insert them into this absolute value of x minus 2. So for -2, it'd be -2 minus 2, -1 minus 2, 0 minus 2, 1 minus 2, 2 minus 2. And number-wise, I'm going to get -4, but absolute valued as a +4. And I'm going to get -3, but absolute valued as a 3. I'm going to get -2, but that makes a +2. I'm going to get -1, but that makes a 1. And I'm going to get 0. So I see that my pattern is going 4, 3, 2, 1, 0. Now on a graph, here's what that's going to look like. -2 is way up at 4. -1 is up here at 3. 0 is up here at 2. 1 is at 1. 2 is at 0. And really all it's looking like is a straight line. But I know with absolute value I should expect a V. So what I need to do is continue my numbers. I shouldn't stop here. Maybe I need to do 3 and 4 and kind of see where this pattern takes me. So if I do 3 minus 2, I get absolute value of 1, which is 1. If I do 4 minus 2, I get the absolute value of 2, which is 2. So I get 1 and 2, which I'm going to put on my graph. Now 3, 1 looks like where I'm turning my corner. 4, 2, there it is. That's my V. So I just needed a couple more table numbers. And now that I kind of see my pattern, I could add more dots if I felt like it to my graph. So now to answer the rest of the question, I'm going to pay very close attention to the fact that it is a less than or equal to problem. It's a shading problem. And an equal to sign tells me that I'm going to connect my V with a very straight, solid line. So I'm going to draw some arrows, extend it, and really I'm down to one thing. I need to test inside and outside of the V. Now I like this one. Outside of the V I could test 0, 0. It'd be a really simple number to test. So I'm going to run up here and I'm going to test 0, 0 in my rule. And if y is less than or equal to absolute value of x minus 2, I'm going to have 0 is less than or equal to 0 minus 2, which is an absolute value of -2, which is 2. So 0 is less than or equal to 2. And you have to say to yourself, is that true or is that false? Is 0 less than 2? And yeah, 0 is less than 2. This one passes our test. If it passes, you can shade. And since it passed on the outside of my problem, what I'm going to be doing is shading on the outside of my V. Everywhere outside of my V. So all of this space will pass. And what that truly means is any point I select out here will always pass in this equation. Any point. Any point I select inside the V will always fail. So that kind of is what this represents. And then there's your solution. Okay, so let's try something else. Let's do a problem C here. For part C, let's change the problem up a little bit. Here is C. Let's graph a system. Let's graph 2 on the same graph. Can you graph y is greater than 2x and y is less than or equal to -1/2 x plus 1? So again, pause the video, do all the work, and then check your answer and see if you got it right. That's the best way you know you're ready for like the next test that comes up on this. Okay, so you've unpaused the video now, and I want to make a point about this one. On the last 2 problems, I kept wanting to make a table, and I like using a table. But with these, I really don't need a table with these 2 equations because I know they're just straight lines. I see them as y equals mx plus b. So I'm actually going to skip the table, and I'm just going to say, you know what, this is like y equals 2x plus 0. I'm going to be starting at 0, and I have a slope of 2. I'm going to be counting up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, And I know that it's going to be just this nice straight line going through those points. Now, I also know that there's not an equal sign with this inequality. It's all greater than. So when I do connect my points, I'm going to be sure to connect it with a dotted line. So I'm going to dot this line. And if I was going to show some extra work, I would show testing a point on the line. But for now, I'm just going to dot it in. And I'll even write the equation. Y is greater than 2x. And then I'm going to test it to determine am I shading on the left side or the right side of this line. So to test a point, pick wherever you feel like. Either pick something over here on the right or pick something on top of it on this left side. Maybe like a 3, 0. I don't know, something easy. So I'll do a quick test of 3, 0 up here. The equation is y is greater than 2x. So we're going to do x is 3 and y is 0. So 0 is greater than 2 times 3. 0 is greater than 6. And then you ask yourself, is that true? Is 0 greater than 6? No, 0 is not greater than 6. This one fails our test. And if it fails, that means on the graph, all of our shading is going to happen on the opposite side. This point failed, everything over here fails. So the shading is actually happening on this side. And then for our next one, we're going to do the same process, just on the same graph. So the next rule, negative 1/2 x plus 1, starts at 1 and goes down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. It's a line going in this direction. And when I line this up and connect my points, I happen to notice that this problem has an equal sign with its inequality, so it is going to be a dark solid line, not a dotted line. It's going to look like this. But I do need to test. Now I need to test. I need to focus. I'm going to put my pencil on the line. I need to focus on that pencil and decide, am I shading above the pencil or below the pencil? Above the line or below the line? And so I'm going to test, how about, well, 0, 0 would be easy, but how about something else? How about up here at 0, 5? It's a little more obvious on the top part of the line. So I'll write over here, test 0, 5. And we're going to test it in this y is less than negative 1/2 x plus 1 rule. So x and y is 0 and 5. I'm going to do 5 is less than negative 1/2 times 0 plus 1. 1/2 times 0 is 0. So I'm left with, let's move this down. I'm left with 5 is less than or equal to plus 1, so 1. So is 5 less than 1? No, of course not. No, 5 is not less than 1. This is another fails, which tells me that this point on the graph does not pass, which tells me all my shading is going to happen down below, down here. So I'm going to be shading on this side of the line. But really what we're truly looking for is where do the two shadings for the two lines overlap each other? Because that's the solution to our inequality. And you can see as you're like shading really lightly, I hope, that the overlap happens right in here. So this is the part where I'm going to highlight it real dark. This is actually the solution right in here. That is the dark shaded region. I'm going to use my eraser just to lightly erase this extra shading because we no longer need it. We only want to find where the overlap is. I don't need this extra shading. I'll kind of take that off my graph. And it's that dark region. And then there's the solution. I'm going to write my rule, my equation, y is less than negative 1/2 x plus 1 next to that one. And I have a system of inequalities. Okay, so let's do one last one for this video since we're practicing. We're trying to prepare for this end of unit test. Try this system. Last one here. Can you graph y is greater than or equal to 2x plus 1 and y is greater than negative 2/3 x minus 3? Go ahead and pause the video and see if you can do it yourself first. Okay, so hopefully you paused the video and did it. Now we're going to check your answer and see if you got it correctly. For this last one, I'm going to try and fly through it a little faster. So it's a rule, an equation that starts at 1 and grows 2. So 1 up 2 over 1, up 2 over 1, up 2 over 1. The inequality symbol up there is a equal to sign, so I'm going to be connecting with a solid line. I would never go this fast on a test. I would slow down and try and make it really nice. I'm going to test a point, maybe 0, 0, since it's on the bottom side of this graph. Test 0, 0. I'm going to quickly put 0, 0 into this rule. Y is greater than or equal to 2x plus 1. 0 is greater than or equal to 2 times 0 plus 1. 0 is greater than or equal to 1. 0 is not greater than 1. Fail. Which means the shading is going to happen on the, not on the 0, 0 side, but on the other side. So over here is where I'm going to be shading, on the opposite side, but lightly. And then the other rule is a -3 rule. It starts down here at -3 and has a negative 2/3 slope. Down 2 over 1, 2, 3. Down 2 over 1, 2, 3. And the symbol is greater than, so there's no equal sign. So when I connect these points, it'll be a dotted line. So I'm going to connect it with a dotted line. Draw some arrows. And I'm going to, again, test the top and the bottom of the line. 0, 0 would be a fine test to do on this one as well. How about we do that over here? Test 0, 0. But now I'm going to be testing it on this top, this equation, this negative 2/3. So y is greater than negative 2/3 x minus 3. 0 is greater than negative 2/3 times 0 minus 3. 0 is greater than minus 3, negative 3. Is 0 greater than negative 3? Yeah, 0 is greater than negative 3. It's a higher value, so that passes. Meaning that for the dotted line, remember I just tested this line where my pencil is. 0, 0 passed this time, so I'm shading up above. So I'm shading this direction. And remember what we're looking for is the dark overlap. So it's this region that should be dark, shaded, and overlapped. And I'll lightly erase this other stuff. Now, if you're getting ready for the unit test and you're thinking about how to show your work and make it really nice and organized, hopefully, first off, hopefully you're just getting all the graphs correct and accurate. But what you can do is you can show testing multiple points in different regions and prove that they pass or fail. Like anything over here should fail. Anything in here should pass. And you could show some multiple tests, and that would kind of show like an advanced understanding of how this system works. I would also be very careful. Don't forget, like all your graphs need scale numbers, and you should probably be careful to write the equations or the inequalities next to each line, especially on a system problem. Those labels are really important. Okay, so that was a really fast review of graphing. Hopefully it helped. Hopefully you paused the video and tried all four and did pretty good with it. If you didn't, maybe go back and watch some older videos on this to get some extra practice. All right, thanks guys.